sockets, and as I said, sockets are low level, so you exchange bytes between different processes. But we are acting with objects, we are working with objects, so when we interact, we want to, between different processes, imagine we have different images on the different processes or different devices that wants to work together, so we want to exchange data, and our data are objects. So we need to, in order to copy an object through the network from a device or from a process to another one, is to transform an object into a set of bytes, send it to the socket, and the other side rebuild from the sequence of bytes, rebuild the objects. And for this, we have reference stream, which allows doing quite easily this task. You have two messages to know. One is stream the representation of. You send this message to the class reference stream, and then you get a sequence of bytes, a byte array, and then you send this byte array through the socket, and at the other side you send the message and stream with your byte array to the local reference stream class, and then you end up with a copy of your object. I insist on the idea it's a copy of the object. So you have, at the end, you have object, the same, the object and a copy on both sides. Another important point is that, of course, you need that the class of the object should be already there. So, of course, at the origin of where the original objects were located, you need the class. But when you rebuild your objects, of course, you need that the class should be there. And then, based on this, we can do remote messaging. So imagine I have the blue object that want to send some message to the yellow object, which is on the other side of the network, or green. Yes, depending on the. Okay, it's a green object. Blue and green are discussing. And so, in order to do the interaction, and if you want to do it in an object fashion way, what we need is that we need a placeholder, a proxy of the green objects in the same image where you have the blue object. So from the blue object point of view, it is simply sending a message. But the proxy, it will transform the message, it will capture the message and transform it into a sequence of bytes and send it to the socket that will transfer it through the network. Then the other socket, the other side, which will receive the bytes, will send it to some dispatcher object that will rebuild the message and then finally deliver it to the recipient. And if you have multiple objects, so multiple remote objects, you need to distinguish which one you want to deliver the message. So the proxy should have the information about the recipient. So when the proxy on the image on the left will receive a message, it will encode not only the message but the ID or some way to retrieve the remote object. So at the other side, the dispatcher will figure out to which object it should deliver the message. And now we arrive to the fourth and final challenge, which is doing a remote transcript. So the idea is that we want to have a transcript that is available remotely from one side in one image and access to it remotely. So send CR and show messages. to do this, we need to handle all these features. So code deployment, that's easy. We have transcripts in all images, so nothing to do at this level. We need to build a proxy on the remote remote transcript. So in one image, we should have a proxy that holds the information or the ID of the transcript on the other image. This proxy should capture messages. Whenever it captures a message, it will transfer it to the socket. So we need to control message, to have message control. And of course, you need to serialize and deserialize message, as we've seen with the reference stream. And we can even go. To make some advanced feature is to provide argument passing by reference. So far, we discussed argument passing by copy. So you send a copy of the object. So if there is a change that is done at the recipient side, it's not reflected on the original side. But if you want to say that to have an object that is unique in both images, and all interaction arrive to this unique object, you need to, when you send it as a parameter to a message or result of a message, you need to replace it not only you need to replace it by a proxy that will be rebuilt on the other side. And there is also garbage collection that can be an issue if you want to have a full middleware, object-oriented middleware. Okay, let's look at some questions. So the question of the proxy and message passing control. So a simple way is to ask Mariano. He's working on proxies, but the one approach is to make an empty object that does not understand any message. And whenever you have an object that whenever such an object receives a message, of course the reaction is that it will trigger the does not understand, message not understood. And there, yes?
I think better term is which traps all messages. It's not does not understand, it just traps all
No, this is, I'm speaking about technique. The idea is message...
implemented using does not understand pattern, but the idea is that the proxy traps all the messages which sent to...
Exactly. What I'm speaking of is message passing control. But one technique is does not understand. We agree. This is important. Thanks. That to be more clear on this point. Does not understand is not the only way, and it's not always the best way. There are other means. So if you want to learn more, ask Mariano and discuss. Sit near him for lunch. So let's do it. So for this, I didn't write the code. So remote objects demo. So ideally, if you want an object to understand nothing, we want it to be a subclass of nil. And say, okay, this is my proxy. But what happens is that if you provide nil as a superclass, the class builder replaces it with proto-objects. Okay, something strange. Wait. Do it this way and this way. Okay, now it works. So let's redo it. Move. Okay, so what I said, I don't want anything in my class. I don't want me to be annoyed by inheritance. So I say my proxy should be a subclass of nil. I accept, but what the class builder replace nil by proto object, because in order to ensure that your object will handle the least, I mean, the minimal set of messages that are required by VM. We can force and change this, but we will not do it so far. We assume that our proxy does not understand much. So if I say proxy, I do new. So proxy print string, and then even print string is not understood. So this is what we want. So some use, most messages are not understood. But so far it relies on the default implementation of does not understand, which raise an exception. So if we want to do message control, okay, should be controlling messages. Okay, does not understand a message. And then here we can do whatever we want. A first example is that to show you what's going on. I will just display on the transcript what is the message. And then now, okay, we can forget this. Here is the workspace. And then where is the transcript? It's there. Okay, let's clean the transcript. And now this time I send print string to my proxy, and I captured the message, and I did something else, which is printing the selector here on the transcript. So what should do a proxy is that the simplest way is to transform. I mean, in our application, in our networking application, we want the proxy to do the job of this little guy, if you remember. We want it to act like this one, this little guy, to transform the messages and their parameters into a sequence of bytes. So we do it by calling, okay, so message bytes, and let's call reference stream representation of a message. And this is not enough. We need to send it. I mean, this is the first level. Let's wait 2 times. So now we have bytes. The next step will be to go through some socket stream and say, okay, we want to send this sequence of bytes, and we can agree on a convention that at the end we will send a CR and LF to say, okay, the data is finished. We finished sending. So this is done by the send command message of socket stream. Okay, what is socket stream? It should be an instance variable in our proxy. But before going on, let's look at the implementation of send command. And if you look at the implementation of send command, it simply puts all the string or sequence of bytes, and then it adds, so there is the comma for concatenation, and then send the CRLF, and then flush, which is okay, send everything through the network, through the socket. And now we have this, so it's almost done. There are two things missing. The first thing is that we are in this case. The proxy points to a single object. I mean, make the assumption that the dispatcher refers only to a single object. We don't have the ID. Remember the problem with the IDs? So we will not take care of this so far. And the other problem is more related to implementation. Is that this socket stream isn't initialized. How to initialize it? If we have a single proxy in our image, that's fine. We can create the socket stream inside the proxy class and then work with it. But what happens often is that we have multiple proxies on multiple objects on the other side, and then we need to share somehow the socket stream between proxies. This means that we need to set up the socket stream instance variable from the outside of the class, which means that we need some messages and at least some accessors. And if we simply, okay, let's abstract it. If we simply add this message, read-write accessors, it does the job, but on the other hand, it does not capture messages that have the same names. So imagine you have on the other side, the remote object should understand socket stream on socket stream colon, but this message will not be transferred. Instead, the proxy will process it itself. So this is why it's not always there are different techniques, and this one is not always appropriate. But it works most of the time. And what is often done, which is, okay, it's a hack, but it's solved the problem, or at least temporary, or some level, is that instead of it's to provide some strange names, to use some strange names that we are sure that are not existing elsewhere in the system. So often it's like XXXX, and then you put whatever you want. So you have something to distinguish such names from the rest. And then usually in application messages or application methods, you don't have selectors like this, because it doesn't make sense to have them. But the proxy, so you use them only on the proxy side to avoid collision between messages that should be transferred to the other image and the messages that the proxy should process by itself. So we should do the same like this, and then we say, okay, it will be XXX. And we accept. Okay. And so now I can create a proxy and connect it to an existing socket stream that is connected to a remote server. What's missing is the dispatcher side. So on the remote image, so I need an extra image. So this one will be the image with the proxy. Let's save it. And now I will create script. Okay. Now on this, now I'm working on the image for the second side. So remember, the application was that we want that our green object is the transcript, and we want to access it from a remote image. So we build the proxy, and now we need to build the dispatcher. Okay, please. Okay, so we are in the remote side, so we don't need the proxy at this side, but we want a dispatcher. And we'll do it quite straightforward. Dispatch message, no, dispatching, we are providing the category. Okay. And then the category will do dispatch message bytes. So it will receive the message byte from socket stream, and it will transfer them in a message. So it will do, to get a message, we'll do reference stream and stream message bytes, and then we have the message. Oh, looks like there is something wrong. Okay, and then all we have to do is that to send the message to the transcript. We are in the case where we have a single remote object, so this is straightforward. This is not enough. I mean, so far what we did is that we have the proxy that can control messages, send them to the socket, and we have the dispatcher that knows how to make this connection. But it remains this lower arrow, the connection between the socket and the dispatcher. And also the connection between both sides, we didn't discuss it. We need to decide who should be the server, which side, and we need to have some way to make the dispatcher get the data, the bytes from its socket, and in order to build the message. So hello. Okay, so one way to do it is, it's an easy way to say we have the dispatcher is actually a server. So remember we had this simple server already available, and then in each time it gets a connection, to handle a connection, it just read the message and perform it, and that's it. So let's do it. So the server, and this way we get also the connection with the socket stream, and I don't remember. It is handle interact, then close, interact through. Okay, we need to implement this message. So we forget about all the details. We know that the socket stream server is the socket stream is created on connection, and once it's there, it will call this method. Okay, interacting. Connections, no, anyway, okay. Let's call it handling connection to have a nice category name, handling connections. And here I have socket stream, and all I have to do is to fetch yes, so at the other side there is a command send, which is sequence of bytes plus CR and LF, and to get it we do next line on the sockets, on the socket stream, next line. So we will get the bytes and then do a dispatch of this, and that's it. So hopefully it will work. Let's try. So I have server, which is dispatcher on ports, say ports 2, 3, 4, 5. What?
Port number.
Port number. Let's see correctly. Okay, let's try again. Okay, this time it works. And server starts. Okay, now let's try go to the image with the proxy. Takes some time to start. Okay, it's there. So let's do. Oh, we need to build the connection to the other side. It's challenge 1. First, we need the connection. Okay, the port number is 2345. Right. Oops. 2345. Do it. Then our stream is connected. Nope. Okay, now I have my proxy, and then I will say CR show. Yes, exactly. Thanks. Proxy XXX socket stream. Okay, and then show hello from the other side. Hopefully it will work. No. There is a timeout. Of course. Why there is a timeout? Wait for data. Why it does not seem that something is wrong. So our connection is connected. This is strange, but basically this is the idea. Up, send command. So send command, send with, or maybe we need to, and what we need to check. So let's try this. Okay, and on the proxy side, let's close and rebuild the connection. So close, rebuild the connection, check if it is connected. That's true. Rebuild the proxy. Okay, strange. Oh, of course, because I did a print instead of do it. Okay. Okay. Almost out of memory. So this is what happens when you mess up with the proxies. And let's write. Okay. Are we connected yet? Yes. Check. And no, again, there is something missing in my. It's
Stream has a timeout second.
yes, but
I think you
I shall do it quickly.
between connecting and sending the data. Just
Do it in one way, in a single evaluation. Okay. Yes, the delay is 2. So the proxy, we shall put it there. And so proxy xxx socket stream, which is stream, and then so close this. Okay. No, something is. This is the basic idea. Okay. I'll get the code already wrote somewhere. I will get it. Abandon. On the other side, nothing. Stream is connected. Last trial. Close this. Okay. No. Last try, and then I switch to existing code. No, it hangs. Maybe I should kill my image and reopen it, because something useful, you do ls off and then grep tcp and grep which is quick VM. Takes some while and you see what's going on, and there are 2 servers listening. Okay, there is kind of on some ports. I don't see the ports. Maybe I better clean, shut everything and restart. This is usually when you are debugging your distributed application code. Usually it helps to kill everything and restart. Okay, up. Because then it's really frees the resources. And I need to stop my server. Maybe I'm having another server running. Okay, save and quit. And now nothing. The proxy image, the server one, what's going on? Nothing open. Okay, that is good. Start the server. Oh, I need to allow it. Yes. Check. It's listening. Okay, perfect. So you see that it's listening. And then let's try it the other side. So create a new proxy. And then, no, something is. So, no, I did do it. But we should have at least one message. No, something hangs here. Okay. Well, I will not debug it right now. Let's take existing code. It's not exactly this one, but the idea is there. Okay. This is the client side. Oh, it's even more complicated. Should show you the right code. But okay, maybe you get the idea. Maybe I should not lose time on this. It's better than, but it works, believe me. So, as a final part of the presentation is what next? What next beyond this sockets library existing in Faro? Actually, there are two directions. It's an ongoing work, which is the Ocean project I already mentioned, which is rebuilding the socket library to have a clean one. And the other one is distributed object with a middleware called RST. It exists since several years. It was done by Diego Gomez, and first implementation, and then we continue try to maintain it and make it work. And actually, from the historical point of view, we start working on a project on ambient intelligence, ubiquitous computing, or whatever you name it. The idea you have handheld devices that discover each other and start interacting in an unplanned way. And we want to do it in the object way, so we start with look into remote Smalltalk, and we had some stability issues, and progressively we discovered that the problem lies into the underlying networking library. So we start trying to fix it, and then we end up with throwing it away and rebuilding it from scratch. And this is the Ocean project. The idea is to have a clean, portable networking library. We looked in multiple libraries in Smalltalk world, but also outside, and most of them, if not all of them, are dirty. Usually you have something like this. So this is the current network library of Faro, Squeak, and you see that you have a single class, socket class, that includes everything. It works for TCP, for UDP, for whatever, for all kind of sockets. So it's a direct mapping with the non-object-oriented sockets from the operating system. So it's direct mapping of the library, which is really, really, really non-objects. And you look at the address side, you have socket address that's inherits from byte array, which is really strange. And there is a mix between IPv4, IPv6, and there is also a mix between the communication and the protocols. You see, HTTP is a subclass of sockets. No, HTTP is a protocol that uses TCP. It should be outside. Same for SOCKS. There are lots of such things. We looked into sport, we looked into visual works, we looked into I don't remember else. We have a list of things that we looked, and more or less it's the same. This is the basic idea. So we decided to start, and besides being dirty, when we start looking at it, there were 0 tests. When I say 0, it's really 0. Now we have few tests that are progressively introduced, but what we wanted is to clean the mess, and we decided to start from scratch and to bootstrap a library. So this is part of our current design. Is we have a socket, and we have a TCP socket on one side, UDP socket on one side, on the other side, and actually this is not completely stable, because we will have a subclass for TCP server socket, another one for TCP client socket. You have a socket for listening, the socket for listening for connections in the server side that does only this, and its life cycle is different from the life cycle of a socket that does interaction. So we will split these two. And of course we have UDP, which is another place. There are hierarchy for IP address I didn't show on this slide. And this socket library is generic, which means that is independent from any the way it is implemented from the low level side. It's independent from the low level side. So we can have so we decouple it. We use the bridge design pattern. So we have the low level side put in a proxy to a library, which can depend on the operating system, and we can have multiple implementation for each operating system. And of course, we want, as we said, we want to be beyond OOP, it will be tested. So we spend lots of energy in writing tests and tests from scratch. So this means that we made no assumption. We didn't use the existing socket. Because we have no way to prove that it's working correctly. So we wrote tests that check with operating system, with the commands such as INC to see what's going on, what we receive on the operating system side. So the current status is that the purple and red squares or classes are implemented. Almost everything is tested. Actually, it's test-driven development. And we thought that it's a too long-term project, and maybe in order to make the result available quickly and make it available to the community, we introduced a new intermediate milestone shown in red. The idea is that we want a clean API for socket, but and the connection with the underlying system is relying on the current existing plugin for networking. The name is socket plugin, by the way. Again, it's a misnamed or badly named plugin because it does networking and the name conversion and all the stuff, which is not only sockets. Anyway, so this is the idea, is that we want our socket library that is independent from the implementation, from the operating system side, and we have a wrapper for the plugin, and this wrapper contains all primitives we found about the plugin. Because in the current implementation of socket, not all primitives are made available. For some reason, lots of them that might be useful, that are useful, were hidden. So thanks to Yannick, we identified some missing primitives and made them available, and we used the socket plugin to discuss with the operating system to allocate sockets and to do all the low-level interaction. So this is our goal for Pharo 1.3. Next step we want to go beyond is to explore a or plugin-free implementation. Actually, this is the starting of our work was based on this. We start by implementing a wrapper for POSIX library, and we relied on FFI that was presented yesterday by Igor to access the POSIX library. Actually, we didn't use plain FFI, we use alien FFI. But it's not, it's not critical. Choosing one or the other is not critical. The idea is that we wrap the POSIX library, and we don't use a specific plugin for the network. And so all the development is done in Smalltalk with FFI calls. So we rely on Smalltalk IDE for all the chain, including the tests. And this proves to be promising, at least at the first test we did. We show that we compare in blue our implementation, or it's our first implementation done last summer, which is faster, a little bit faster than the current existing implementation socket. And this is actually just a first step in a broader project. We aim to generalize it. So the idea is to end up with smaller VMs. That is, in most cases, we are not sure that the plugin is really useful, and we can live with FFI. And the idea is to experiment with other libraries and to remove their plugins and to end up with the smaller VM. In the VM side, we'll have the minimum stuff, which is the interpreter, the garbage collector, maybe a JIT. Although the JIT, sometimes there are some implementation that can be at the language level, and that's it. And everything is at the level at the image side. So you have all libraries that goes through FFI and call the appropriate system libraries. And that's it. So we are ahead of schedule.